Hi everyone, this is Anu. Me and my teammate Chandu worked on the project Insider Threat Detection dealing with feature engineering and sampling techniques. Firstly, let me define insider threat. So, insider threats are malicious acts carried out by the organization's employees who abuse the authorized access to systems and data through carelessness or revenge. For this project, we use CMU's CERT dataset version 4.2 as it has more insider threat incidents than the others. It consists of four different events: log on, log off events, email transmissions, devices, and files. As we can see here, ID represents the user ID, date is the date of occurrence, PC is the PC that is the device that the user uses, and activity refers to log on, log off, connect, or disconnect. Here is some of the previous work done in the domain of insider threat detection till date. These are all the models used, and we can see that the highest accuracy attained is 94.5% when using the graph convolution networks. The second highest is 94% using random forest with randomization. So this is the dataset which we take, and we see that there are 1000 employees amongst which only we have 70 insiders. So this dataset is highly imbalanced. All the previous works lacked balancing techniques as the data is imbalanced towards non-malicious records. Our research goal is to focus on these techniques as well as feature extraction and to compare our work with previous work. We also evaluated accuracy post balancing techniques. The step 1 is feature extraction. We extracted 17 different features from the .csv files provided and then aggregated these features with the user ID and date. We then counted the frequency of each feature for a particular user and identified them as malicious and non-malicious based on a criteria defined by us. This gave us a target column which stands for 1 for malicious and 0 for non-malicious users. These are the list of 17 features which we derived from a dataset. Everything that ends with normal is a non-malicious, and the other features include like if the user logged in between 8 to 5 p.m. or sometime afterwards, if the user logged in during a weekday or a weekend, and the type of file that is transmission, and the email is sent within the organization or outside the organization. We took all these 17 features into consideration and then proceeded to vectorization where we created a 3D array. So for every user, we created a 2D array with the 17 features as the rows and the number of days the user worked as columns. We later on converted into a 2D array which yields us 9000 features per user in the dataset. We employed 4 sampling techniques to balance the target classes. These are SMART analysis. The ADASN stands for Adaptive Synthetic Sampling Approach. SMART plus ENN, edited nearest neighbors. SMART plus Tomic links. Tomic links is a form of condensed nearest neighbors. We selected logistic regression, SVC, random forest, AdaBoost, isolation forest, and CNN as our models, as they offer adaptability and flexibility for imbalanced datasets. We evaluated all the models chosen by us on the following metrics. Those are accuracy, precision, recall, and F1 score. So here are the experimental results. So we initially performed SMART technique on all our models and then got an accuracy. So SMART adds synthetic data and is an oversampling technique. We see that the highest accuracy obtained is 95% for logistic regression and SVC, followed by CNN, which got an accuracy of 94%. The second technique employed was ADASN, which stands for adaptive synthetic sampling. It is also an oversampling technique, but this takes care of distribution density. So here also we see that CNN attained an accuracy of 96%, which is highest, followed by logistic regression and SVC, with an accuracy of 94%. The third technique employed by us is SMART plus Tomic links. This is a hybridization technique. SMART, as I said previously, is an oversampling technique, and it can add artificial data leading to the overfitting of data. So that's why we use Tomic links. In Tomic links, we choose random data from majority class, and if the random data's nearest neighbor is data from the minority class, then it removes it. So Tomic links is a data cleaning technique that focuses on eliminating borderline instances that cause ambiguity. Using this technique, we see that both logistic regression and CNN attain an accuracy of 95%, followed by SVC with an accuracy of 92%. The last technique employed by us is SMART plus ENN. This is also a hybridization technique. In ENN, the nearest neighbors of each of the majority class is estimated. If these nearest neighbors misclassify that particular instance of the majority class, then it gets deleted. Therefore, this method is useful for eliminating noisy synthetic samples. So, using this technique, we get an highest accuracy of 95% using CNN, followed by an accuracy of 93% which we got in logistic regression and SVC. So, for the dataset which we used and the models which I already showed previously, we see that our model, which is a combination of ADASN sampling technique with convolution neural network, gave us a highest accuracy of 96%, which is greater than 94.5%, which we got from graph convolution networks. In conclusion, we tackled the class imbalance using 4 techniques, and ADASN combined with CNN gave us a highest accuracy of 96%. Also note that CNN always attained highest accuracy on every sampling technique, followed by logistic regression and SVC. Furthermore, we would like to explore other datasets in real time and investigate deep feature synthesis in diverse domains. Thank you.